Okay, so today we're going to review some rules about functions, and while we do that, I'm also going to introduce a little bit of notation. So at the top of page 31, it says that a function f is a set of A to a set B is a relation that assigns each element x in set A to exactly one element y in set B. So I just want to draw for you. So I have set A, and A is full of lots of x's, and I have B that is full of y's, and each one of these x's is assigned somewhere. The set A is the domain, so these things over here are the domain. And over here, these y's are the range, or the outputs. This means that every x must go to a y, but not every y will have an x. So I want to give you my little classroom analogy, which I also use down below, which you can see in the screen right now. So my classroom analogy is this. All of you guys, all of the students make George Ranch a function. You make us function and you are the function. So when we put you into the school system, what you guys call Family Access or Skyward, you all get a schedule. In each period of the day, you have to go somewhere. It might be off campus, it might be athletics, it might be to math class, wherever it is, each period of the day, 1 through 8, you are assigned to go somewhere. However, you, my little x's, cannot be assigned 2 places to go, 2 y's. You can only go 1 place. But, for example, this period, all of you are assigned to me in 2412. So all the x's can go to 1 y, but all of the x's cannot go to different y's at the same time. And then there's some more characteristics, which I'm going to highlight with my example. Each element of A must be matched with an element of B. So each one of you, each period of the day, has to go somewhere. Some elements of B may not be matched to any elements of A. So for example, my conference period during the day is 5th period. So during 5th period, I don't have any x's attached to me. 2 or more elements in A may be matched to the same element of B. That's like this classroom. All of you are assigned to come to 2412 for this class period. Finally, an element in A, the domain, cannot be matched to 2 different elements in B. You cannot go to 2 classes at the same time. So then down below on this page, you can see I've filled in what verbally, numerically, graphically, and algebraically mean, and I've given you an example of each one. So verbally means using words, and this classroom schedule example I have given you is an example of that. Numerically means with numbers, so you can use ordered pairs or a mapping. A mapping is, you use these a lot in Algebra 1. They would say these are the x's, and they would say these are the y's, and they would draw them across like this. That's a mapping. Graphically means you use a graph, and I drew one, and then you would use what you guys call the vertical line test and draw your vertical lines to see if it touches, if the graph touches a vertical line more than once. And then algebraically means with algebra with an equation, which I've given you. And speaking of algebraically, go ahead and pause the video and then copy this down, and then we're going to go to the next page, and there's something we need to talk about with the algebra. So at the top of the next page, it says another way to think about a function is any function that can be uniquely solved for y. And so uniquely means that you're one of a kind. You're the only solution for y. So what we're going to do is we're going to use our algebra skills, and we're going to isolate y in the equation written. So I'm going to add my x and minus my 1. If I do it on one side, I have to do it on the other side. So now I'm going to have y squared equals x minus 1. Now to undo a square, you're going to take the square root, take the square root. But here's a big rule. So a really, really big rule. So I'm going to minimize what I was doing over here. And it's such a big rule, I'm going to write it down for you. If you put a square root on a problem, you always need the plus minus. Because the square root wasn't there to begin with and you've put it on the paper, you have now changed the problem if you just leave it the way it is. Because you should be able to tell me that the square root of 4 is not only 2, but negative 2. So the square root of 4 is plus or minus 2. And because we have put a square root on the paper, we need to take care of the plus or minus. So here we go. So I put the square root on the paper. So now I'm going to have the y, because the square root of y squared is just y, is going to equal plus or minus x minus 1. So let's plug something in. Let's just, I don't know, let's try 5. So if I let x equal 5, I'm going to get plus or minus the square root of 5 minus 1, which is plus or minus the square root of 4, which we know is plus or minus 2. And when I plugged in 5, this 5 is being sent to two different values. The 5 is supposed to go to 2, and the 5 is supposed to go to negative 2. But you, my little x's, cannot go two places. So this plus or minus 2 is not unique. There were two solutions that came out, which makes them not unique. And that means this, if you were to graph it, would not be a function. So what I want you to do for a second is try the next two examples, and it says which of these equations or equation represent a function of x. So pause the video and try the next two examples. So example 1 is a function because when you solve for y, no matter what you plug in for x, you're only going to get one answer out, making that answer unique. But for number 2, when you solve for y, you have this plus or minus square root thing again, and so no matter what you plug in for x, you always are going to get two answers out, the plus version and the minus version. So the next thing we're going to review is function notation. So I have some function, its name is f of x, and in this case in your notes it's named 2x. So this thing right here, the f, is the name of the function. This x thing is what you are plugging in over here. It's the input. And this thing over here is what we call the function rule. It's what happens to the input. So in this case, we take the input x and we multiply it by 2. So at the bottom of the page, the first thing they want us to do, first thing they tell us is that we have a function g of x equals negative x squared plus 4x plus 1. So part 1 wants us to find g of 2. So g of 2, and you're going to notice that whenever I plug something in, I just put parentheses. So it's going to be negative something squared plus 4 times that something plus 1. And I do that so I don't mess up the plus and minus signs. So I'm going to plug in my 2, 2, 2. So we know that 2 squared is 4, and the negative out front makes us a negative 4, plus an 8, plus a 1. So our answer is going to be 5. So g of 2 equals 5. Number 2 is super easy because it's g of t. And all that means is that all the x's are becoming t's. So it's negative t squared plus 4t plus 1. Now, the hardest one of all is the last one because it's going to involve some algebra and some foiling. So I want you to take a second, go ahead and pause the video, and I want you to try to find g of x plus 2, which, let me help you set it up. It's going to be negative x plus 2 squared plus 4 times x plus 2, and then plus the 1 you had on the outside. So go ahead and try. So the first thing I'm going to do is have my negative on the outside. When you square this, you get x squared plus 4x plus 4. You cannot, this does not equal x squared plus 4. You have to actually FOIL it out. Plus 4x plus 8 plus 1. Now I'm going to distribute the negative I had out front. So negative x squared minus 4x minus 4 plus my 4x plus my 8 plus my 1. This negative 4x and this positive 4x are going to cancel out. So g of x plus 2 is going to equal a negative x squared. I don't have any x terms left. And then negative 4 plus 8 plus 1 we know is plus 5. There's my answer. On the top of the next page, we get into piecewise functions. So piecewise function is a function that is defined by two or more groups of equations, right here, two or more groups of equations, over a specified domain. So this is the algebraic version. Whoops. This over here is a graphical representation, or a graph. And then it says evaluate the function when x equals -1, 0, and 1. So we have two different functions. We have this red one that's the algebraic version and a green one that is the graphical version. So we're going to do each one. So let me minimize this. So if I wanted to do the algebraic one, so x equals -1. I need to use the bottom piece because -1 is less than 0. So that means that I'm going to have -1 minus 1, which is -2. So for this part, x equals -1 is going to get -2 as the answer. If I do x equals 0, again, need to use the bottom part because in the domain on the side, 0 equals 0. And so you're going to get 0 minus 1, which is going to get you a -1. And then finally you get 1, and you need to go use the top part because 1 is greater than 0. So x equals 1, we're going to use the top part. And we're going to do 1 squared plus 1, which is going to get me a 2. On the other graph, we're going to guesstimate to the best of our abilities. But if I want to do x equals -1, I'm going to guess that -1's right here, and we're going to go up to the graph, and we get a value of, I'm guessing that's a 3. And if I did x equals 0, well, right here's where x equals 0, so we're going to go up and down, but both of those are open circles, so there is none because open circles are not included. And then x equals 1, that's where x equals 1, and if we go back over the y-axis, the height of that point is 0. Okay, and so now that we've looked at open circles, let's review them a little bit. So open circles versus closed circles. So open circles are what we use for less than or greater than, and they're the parentheses. And closed circles are what we use for the less than or equal to and the greater than or equal to, and they are what we use when we have brackets. Closed circles means it's included. Open circles means it's not included. So first of all, I would like you to assume that there's arrows on the ends of those two pieces. And on this piece, there's not. You can see right here, there's an open circle. So we're going to write the domain and the range. So domain is all the x's. So we're going to move along the x-axis until we have a problem. So let's think about this. So we're moving along our x-axis, and we have values. They're all down here. We're good, we're good, we're good until we get to here. Right here at -1, we have a problem. So for our domain, we just started off in negative infinity, and we walked until we got to -1. And -1 had an open circle on it, so we're going to put a parenthesis. And then we jumped, so we're going to put a U, and we're going to jump all the way to x equals 1. And I put a bracket because right here at x equals 1, we have a closed circle. And I'm going to go from 1, and I'm going to walk, 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 walk. And even though there's an open circle up here, if you go down here, at x equals 3, I have a closed circle. So I touch 3, and then I keep going. La, 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 forever. So, comma, infinity with a parenthesis on it. Let me erase this yellow so I can now find you the range. Okay, so if I want to find the range, let me use red this time. Range is up and down. So we're starting down here in negative infinity, and we're good. And we go up, 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 until we get to right here, this open circle. 2. Well, this open circle doesn't touch 2, but this one and this one do, so we're okay. And we get to keep moving up, 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 until we get to 6. And after 6, I don't touch 6, and I don't touch anything higher than it. So what we just did was we started at negative infinity. Oops. Not negative 0. I started at negative infinity, and I went up, 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 up until I got to 6. And 6, I'm going to have a parenthesis because it was an open circle. You need to go back to this Canvas page where you got this video from, and there are two more videos for pages 34 and 35.